So in this problem, it is given that x lies between 0 and 2 pi. We need to find out the value of sine x over 2, cosine x over 2 and tangent of x over 2 whenever the tangent of x is given by -4/3 and the value of x is such that it lies in the second quadrant. Let us begin. Now, we need to find out the value of sine, cosine and tangent each with an angle of x over 2. So what we'll do, we will use the given value of the tangent function. So it's given here, the tangent of x, that's equals to -4/3. That's a negative value because we are in the second quadrant, and we know that in the second quadrant, the tangent is a negative value. Now, using the value of the tangent function, we will try to find out the value of the cosine function. So earlier, what we'll do, we will consider, there's an easy trick that we can use. So we'll use a right angle triangle. Let's consider this acute angle as x. Then it's given here that if we take tangent of this angle x, now here what are the sides? The sides are that we have the altitude of the perpendicular, then we have the base, and then we have the hypotenuse. Here, the perpendicular, if we use this value, the tangent of x is 4/3, then we know that tangent of x is also defined as the perpendicular over base. So that means we can consider the perpendicular to be 4 and the base to be 3. And when we use the Pythagoras theorem, then the hypotenuse comes out to be 5. Now we can immediately find out the value of cosine of the angle x. So cosine of angle x, so that's the base over the hypotenuse, so we will have 3/5. And since we are in the second quadrant, it's going to be negative because in the second quadrant, cosine is a negative as well. Now, let's try to find out each of the values. So we need sine of x over 2. Now, the reason why we found out the value of cosine of x, because there's a standard formula. Sine of x is given by the square root of 1 minus cosine of angle x divided by 2. So let's substitute the value of cosine of x with -3/5. So this is going to give us, we need have square root of 1 minus of -3/5. So we get +3/5 whole divided by 2. And when we simplify this, we're going to get the value 2/square root of 5. Now actually, it's always a plus or minus value. So it could be either plus or it could be negative. Now we'll have to make sure. Now it's given here that we have the x lying in the second quadrant. Now in the second quadrant, it means that the value of x is going to lie between pi/2 and pi radians. But we need the value of x over 2. So what we'll do, we'll divide throughout by 2. So we're going to get pi/4 less than or equals to x over 2, which is less than pi/2. Now here we have x over 2, which is lying between pi/4, that's 45 degree. It's greater than 45 degree and less than 90 degree, which means that x over 2 belongs to the first quadrant. Now because x over 2 lies in the first quadrant, so that means sine x over 2 is going to give us a positive value. So we'll only take one of the value, that will be +2/square root of 5. Okay, so let's now try to find out the value cosine of x over 2. So here also we have a formula. We have plus or minus the square root of 1 plus cosine of angle x divided by 2. So we will substitute the value of cosine of x with -3/5, and when we compute the value, we should get 1/square root of 5. And this is going to be a positive value, positive because x over 2 lies in the first quadrant, so cosine of x over 2 is going to give us a positive value in the first quadrant. Then now that we have the value of sine x over 2 and cosine of x over 2, we can easily find out the value of tangent of x over 2, which is nothing but the ratio sine x over 2 to that of cosine x over 2. Okay, so that means we have 2/square root of 5 divided by 1/square root of 5. So this is going to give us a value 2, and it's going to be positive because x over 2 lies in the first quadrant. Then the first quadrant tangent is going to be positive. So these are the values of sine x over 2, cosine x over 2 and tangent of x over 2, provided tangent of x is given as -4/3 and x lies in the second quadrant.